Hello and welcome to Golden Geography. Today we're going to be thinking a little bit about the Nant Ffrancon Valley, which is found in Snowdonia in North Wales, and we're going to be looking at this as an example of a valley glacier. So here's the spec bit. We are looking at this as a case study, and we're looking at one landscape associated with the action of valley glaciers. We specifically are looking at three different factors: the physical factors which influence the formation of landforms within this landscape system, the interrelationship of a range of landforms within the characteristic landscape system, how and why the landscape system changes over time, from millennia to seconds. So we're going to start with the physical factors which influence the formation of the landforms within this glaciated landscape system. So there are 6 key factors that we're going to consider: the geology, the climate, the latitude, longitude, the altitude, aspect and relief of this area. We're going to start by thinking a little bit about the geology, and here we have an image from the main geological website that shows us some of the geology of the area. We have, as you can see, a whole range of different colours here, indicating that actually there's quite a mixed geology in this region. If you're looking for the valley itself, you want to be looking at the green road. This is the road that runs along. This area here is where Cwmidwell is, and the valley, the Nant Ffrancon Valley, follows the road north. So here you can see the river that runs along the bottom of the U-shaped valley, and we've got a lot of sedimentary geology there that has been deposited by the glacier and by the river over many years. But either side of it we've got variations in geology, and what is notable is that there is a significant amount of metamorphic rock here. This area is well known for its slate, and slate is a form of metamorphic rock. It was a mudstone that under pressure was changed into slate, often used for housing. So key economic activity based on the geology of this area, but metamorphic rock is quite resistant. We also find granitic rock here, so the granite that was formed when this was a volcanically active area is still present, and that is very resistant. So we do have variations in the type and resistance of the geology here. Over time, that granite has moved closer to the surface as there's been periods of ice ages and erosion, and that's now quite evident in the Nant Ffrancon Valley. Of note is Pit's Head tuff that runs through the valley. It's a type of rhyolitic tuff that is very, very resistant and is important in the formation of the Corrie Lip at Cwmidwell, but also the Roche Moutonnée that can be found within the Nant Ffrancon Valley. Of similar importance is the climate. Today, North Wales has quite a moderate climate. During the winter, there's often snowfall in the areas of a higher altitude, but during the day, it's quite moderate like the rest of the UK. But historically, the key thing was that the climate in this area was cold enough to support the formation of ice. So if we look at the last ice age, 10,000–12,000 years ago, there were very cold conditions here throughout the year, all year round. Harsh winds, cold temperatures that meant that snow could accumulate and build up into glaciers. And actually the area we're looking at was covered by a Welsh glacier, a Welsh ice cap that actually merged into the Irish ice cap in the Irish Sea. But the conditions were cold enough for the ice to stay and to develop, and out of that Welsh ice cap came the Nant Ffrancon Valley glacier that we're going to look at. Latitude and longitude of this valley is really important too. We've got latitude of 53 degrees north, and it is 4 degrees west. Or -4 degrees west. So we are looking here at the kind of perfect environment for it to be deglaciated now, but to still have some cold conditions and some geomorphic processes taking place. But it was far enough north that it was covered by the last ice sheet at the last ice age, during the last ice age 20,000 years ago. So it's that perfect environment of in the past covered by ice, but today is not. So latitude particularly important when we think about this environment. In terms of altitude, the floor of the Nant Ffrancon Valley is about 350 meters above sea level, but when we are looking at some of the surrounding areas, you're looking at a much higher altitude. So you're looking at a difference of potentially 750 meters between the floor of the Nant Ffrancon Valley and some of the highest peaks that we have in the surrounding area. And they are very close by. Obviously it's a U-shaped valley and the valley floor is very close to some of these peaks. Altitude is important. That height enables it to still experience geomorphic processes today because of those colder conditions at altitude. We also have aspect and relief. So the Nant Ffrancon Valley itself runs kind of north-northwest. And what that means is that its two faces give it a distinct difference when it comes to the aspect. So if we are looking just to this section here is north facing, and all of these are small quums and corries that have produced hanging valleys that flow into this Nant Ffrancon Valley. So this north facing slope is very much sheltered because of that aspect, whereas the south facing slope on the other side is much more distinctive in terms of the clear contour lines showing the height, but there's less features there. So it doesn't have those corries because it was prone to sunlight being more of a south facing slope. So that sunlight, that thermal energy prevented snow from settling and producing ice. So what about the interrelationship of the landforms we have here? It's quite a linear progression, so we find that the formation of one landform leads on to the next. So we're going to start with the corrie, Quimidwell. It's found right at the heart of this area, and it's at the head of the valley. It's a beautiful corrie. It's quite unusual in the fact that it is linear in shape. Most are very round, whereas this is a more elongated shape. It's 1.5 kilometers in length. It's got a beautiful tarn in it that is quite distinctive too. But there are still processes going on here. So there was a lot of erosion and plucking taking place during the last ice age, but there's still geomorphic processes are taking place here. But the corrie is very much the start of our glaciated landscape. Here we have truncated spurs. So this is one of the first regions that we have. This is found at the base of Yibgribin. Yibgribin is an arête between Quimidwell and its neighbouring corrie, but this bit has been truncated, it's been cut off, and you can just pick out the person and the helicopter there that shows how this area has been cut by the movement of a glacier. We have a roche moutonné here. This is found in the Nant Ffrancon Valley itself, about halfway down the valley, and it's a very resistant type of geology. It's a rhyolitic tuff, a pit's head tuff specifically, and you can just see in the background that the band of geology is starting to go up the side of the U-shaped valley as well. But here, this very particular shape of the roche moutonné is very distinctive in the landscape. It's where the glacier had to move up and over this very resistant rhyolitic tuff and couldn't abrade it the same way it could the surrounding valley, the surrounding geology. And then much further beyond the Nant Ffrancon Valley, but featured as a depositional, or rather glaciofluvial depositional feature, is the formation of kames, which you can see here marked out in the red. And we've got lots of extra areas of sediment that's being deposited around it, but this cone shape was deposited as the glacier retreated and melted and moved up the valleys. This is a depositional feature. It's actually a glaciofluvial one, so created by the meltwater in the glacier as it ablated during deglaciation. So they are all related. All of these features tie together. The Corrie Quimidwell is the very start of our glacier. If we didn't have that, we wouldn't have any of the subsequent landscapes. So they are interrelated. One is dependent on the other. If we didn't have Quimidwell, the Corrie, we wouldn't have a glacier. If we didn't have the glacier, we wouldn't get truncated spurs. We wouldn't get U-shaped valleys. We wouldn't have roches-moutonnées. They're all related to other. Sometimes these can be found in different orders, so you might find that further down the Nant Ffrancon Valley you have other truncated spurs as well. And then eventually you get to areas like Pentir where you find your cames but also eskers in this area. There are moraine deposits as well, all related. We need to have the Corrie. So we have the start of the glacier, the glacial valley and landscape features within that, and then areas beyond that glacial valley, beyond that U-shaped valley, where we get depositional features, both straightforward depositional and also glaciofluvial depositional features. So without that initial stage, we wouldn't have any of the other landscapes. We need to have the Corrie in order to have these other landscape features. So how and why do landscape systems change? Well, it's a long process. Before the Nant Ffrancon Valley, there would have been a V-shaped valley that was probably drained by a river that ran through the centre of it. And that then was taken over during that ice age. And glaciers, just like rivers, want to find the easiest route to the sea. So glaciers very often followed V-shaped valleys, which had been drained and eroded by rivers, but the sheer bulk of the ice meant that it changed it very slowly over very long periods of time, making those V-shaped valleys deeper and wider and changing them into a U-shaped valley. And in some cases creating things like hanging valleys, where we have differences in the rate of erosion between areas, between glaciated large regions and valleys and areas that are much smaller. So these processes, this abrasional process, takes time, but it can make big changes to the landscape. They're a long-term process. But we do get short-term processes too. Not so much during ice ages, but particularly today in our more modern climate, where temperatures fluctuate around zero, we do get geomorphic processes such as weathering, freeze-thaw and frost shattering taking place. And that has enabled debris to become loose, particularly on the back wall of the Corrie at Quimidwell, and that material to fall, as you can see in this photo here. Those rocks have built up and built up, and eventually the pressure and weight of them and gravity has caused this rockfall to occur. And it happens on a regular basis, so it is something that happens quickly, but it does happen and is changing still as landscape. This landscape is ever evolving. We can get some depositional changes as well, particularly when we're looking at times of deglaciation at the end of an ice age, and you can get seasonal changes there, particularly in association with eskers and cames, where you get more deposition during the kind of summer period where you get meltwater carrying more material. But in terms of very rapid changes within our glaciated landscape today, rockfalls is the main event. Okay, some quick questions. So pause the video, see if you can answer these questions. Okay, here are your answers. If you're not sure about any of these, feel free to go back and have a little look at these again. Here we have some essays. The 16-mark essays are found within the A-level paper. and these are questions that you could apply your Nant Ffrancon case study to. Do make sure that when you're writing that you put in some theory, some context, some geographical knowledge first before your case study. Your case study is to illustrate what you've already written about. And then after that, in order to get your AO2 marks, make sure you do some evaluation or discussion or analysis of what you've written. So very often you're talking here about the significance of different factors that you've discussed. Which is more important when, under what situation is that factor more important? Okay, thank you very much.